Okay, so Parallel Agile is our attempt to enable large team development for software engineering. It's kind of like there's an old saying in basketball, you know, a good big man beats a good little man, right? So sometimes you'd really like to be able to take a big software project and throw a large team of people at it and get it done quicker. And the conventional wisdom in the industry has been that this is impossible. But we've been doing it here at USC, and we've been having really good luck with it. It actually started in this classroom in 2014. Professors Boehm and Kulmanajwang have been in the habit of inviting me to give guest lectures just like today for several years now. And back in 2014, I had an idea for a project that I wanted to get designed. It was a location-based advertising system, basically mobile coupons using geofencing so that when you walk up to a store, you get a coupon on your phone right before you get to the front door of the store. So when they invited me back in 2014, I said, sure, why not? And if you want, I can grade a couple of UML homework assignments for you. And they said, okay, sure, that's cool. There were 47 students in the class that semester. So I took my mobile coupon system and I split it into 47 use cases, and we handed out one use case to each student in the class. And the homework assignments, there were two homework assignments. First one was called Build the Right System, which is basically requirements modeling. Second one was called Build the System Right, which is basically design. And as I was grading the first homework assignment, I realized that this thing was going to go pretty well. And I suggested, you know, if you like, you can assign an optional extra credit where students can deliver a prototype of their use case. And 29 students decided to do that extra credit assignment. And I said, and we better keep track of how many hours they're spending. So we did. We tracked hours on the project. And what it sorted out was it was across probably about 4 weeks. I think the two homework assignments each had a 2-week, time span. And it wound up being 8 hours per use case, or 7.7 hours on figuring out the requirements, 7.6 hours in doing the design, and then 12.7 hours to write prototype code and test it. And it totaled out to 26 hours per student. But I looked at that number and said, yeah, this is pretty good, because multiply 26 hours per student times 30 students, and we just got a whole bunch of hours worth of work done for not very much calendar time spent. Okay, and so that told me that, large-scale parallel development actually is possible. And we spent the last 4 years now repeating this process. Okay, and at the highest level, the process is you basically spend some time when you're starting the project to set it up so you can do parallel development. And then you do everything else in parallel. One use case at a time. You basically figure out your requirements, figure out the design, and build it. And so what we do in Parallel Agile is we basically apply the spiral model, but not across the whole project as a large entity, but we apply it one use case at a time. So we split our system into use cases, and then we go through this ICSM spiral. And it starts out as build the right system, build the system right, test what you built. Another way to phrase it is you go through a proof of concept phase, you go through minimum viable product, and then you optimize it. And then the techniques we use is we do a lot of prototyping in the proof of concept phase. And we combine this, we kind of have a little secret in the mix to make this work, and that is we have a code generator. And the code generator lets us take a UML domain model, which is a class diagram, and it turns it into, at the moment, MongoDB with a collection per class and Node.js. And each of those classes has all the common database access functions, what they call the CRUD functions, create, read, update, delete, all code generated. And it turns out that doing that code generation at inception on the project enables large teams to communicate together more effectively and to integrate their work. Okay, so we run this code generator right up front at the beginning, and then we go through use case, decompose our use cases into model view controller, and then we do testing, and we focus on acceptance testing while we're optimizing and tuning the software. So that's the spiral model on a per use case basis. So basically, again, I'm going to be a little bit from the Department of Redundancy department today. And if you haven't heard of the Department of Redundancy department, you will when you graduate. Basically, we split the system into its use cases, and then we run through this spiral model life cycle on each individual use case. And everybody's working in parallel. So what happens when you do things in parallel is that the number of hours you work doesn't really change that much, but the time on the calendar changes dramatically because everybody's doing that work in parallel with everybody else. So you can get quicker schedules and shorten your time to market. And shortening your time to market is a big deal, okay? And so you can do large systems by just adding more people to your project. So when we set up for parallel development, what we're going to do, again, is we're going to generate a REST API from a domain model. And that REST API, which in our case is Node.js, the REST API includes all the common database access functions, right? So if you go back to my mobile coupon system, if I had a coupon as an object in my problem domain, then I draw a box on my UML class diagram, and I label it coupon, and I put whatever attributes it needs in it, you know, like the dollar value or whatever, the expiration date, whatever attributes a coupon needs, image. And then you run the code generator, and then I have the ability to create coupons in the database, read coupons from the database, update coupons, delete coupons, right? And it just happens, bang, right at the front of your project. I put this infrastructure in place. It's basically the database infrastructure for my project. It gets put in place immediately, and then I can start working in parallel, okay? So I model the problem domain. I generate my database access code and my API from that domain model, and then I partition my system into use cases. I organize them into packages, and I start assigning developers to the use cases. So when you're assigning developers to the use cases, now you care about what's the background of the developer. So if my system needs an iPhone app and an Android app and a web app, okay, I'm looking for iPhone developers, Android developers, AngularJS developers, right? And we've been doing this in CS570 on multiple projects for the last few years, and we've assembled some pretty interesting data from it. So we've taken the code generator, which started out as PhD research from a student some of you may know named Boehm. So we've now taken that code generator and commercialized it into something called the Parallel Agile CodeBot, which you can try for free on parallelagile.com. And it basically, in under a minute, it creates all this stuff. So I start with a class diagram, which is my domain model. And 60 seconds later, I have a Mongo collection for every box on my class diagram. I have Node.js code to create, read, update, delete stuff in Mongo. And then I have API documentation, and I have a JavaScript client and a Java client. Okay, so I have client-side code, server-side code, and it basically is all this database infrastructure for the project. Comes for free before you really get started doing any developing. Okay, and then this is from one of our test projects, which is called KarmaCam, which is turning into a viable business in its own right. So KarmaCam, this is the KarmaCam architecture. We have an iOS dashboard camera app We have an Android dashboard camera app. We have an AngularJS web app. We also have a bunch of machine learning stuff that got added after this diagram got drawn. All of these things communicate through Node.js and talk to Mongo in the cloud. So since then, we've added TensorFlow and Python clients that also use the REST API. One of our other projects is a game project called TQMan Go that uses Unity 3D instead of AngularJS. Unity kind of replaces, the app. We build an iPhone app and an Android app from Unity, but it still communicates to Mongo through Node. Okay, so KarmaCam is a mean stack app, and we've had over 100 CS590 students work on this system over about the past 3 or 4 years. So I started KarmaCam because I got upset at a bad driver who made an illegal U-turn in front of me while I was driving to my consulting job. And I realized that I could go get CS590 students to go build this thing for me, right? So first day of class, so we now call them traffic incident reports and not bad driver reports because people had a bad reaction to the term bad driver report. But the initial domain model was I have a bad driver report. It has a video attached to it. It gets posted to my account. So the report poster has an account. We have independent reviews on this. So it's a crowdsourced app. And we basically took this domain model, generated an API from it, and then started prototyping right away. Okay. So now the CodeBot generates API documentation. So here's one of the things we were building was machine learning video cropping tool that cropped the video instead of the 20-second default video that we get when we upload the thing. For training the machine learning stuff, you want to focus that in on only the 1.5 seconds that shows the incident. So this is we have an incident start and an incident end, and we have an image for each of those that goes through computer vision, OpenCV, TensorFlow analysis. But we generate that, and so you can get, put, post, all these functions are just built for you, and you don't have to code them by hand. And if you've ever had to build these by hand, it's a lot of work. It's a lot of work, and it's kind of boring, repetitive code, and it's error-prone because it's boring and repetitive. So having it generated is a pretty great benefit. So you basically don't need to write this whole database access layer of your applications by hand at all. Okay, that's all just built for you. And if you try the CodeBot on the Parallel Agile website, what you'll find is that your API is actually automatically hosted for you on AWS Lambda. So you run the code, you basically draw a class diagram, generate the code, and your API is live and ready for testing on AWS Lambda just immediately. So we put a lot of work into this infrastructure. Once your database and API is generated, then you start going through use case analysis. And the use case analysis is first you split your system into its scenarios. And then you can do either of these or both. But if your use case is high risk, and what I mean by risk is kind of technical risk. Like, for example, in KarmaCam, when I first started speccing this system out, I was pretty intent that it was going to have a voice-activated interface. So I would actually talk to my phone on the dashboard and say, now go upload this video. And so we prototyped it. We prototyped it with 2 different voice recognition toolkits, and we acceptance tested it. And we got it so it worked in the classroom, but when you put it in the car with ambient noise, it wasn't reliable. Sometimes it wouldn't upload videos. Sometimes it would upload videos when you didn't want it to, and we just couldn't get the reliability to where we wanted it. So we backed off to a one-touch interface. Just tap the screen and it uploads the video. It works much better. So anything that's high technical risk, we absolutely prototype it. If it's straightforward, like, account management login, sometimes you just write the use case, discover what the requirements are. And then my background on this is I've written half a dozen books on use case-driven development, which you can find on Amazon if you type my name into it. But one of the keys to doing use case-driven development successfully is you take your use case description and you turn it into models, views, and controllers. Okay, you guys all know the MVC design pattern? So most people think of model view controller more as a code level design pattern, but it turns out the right way to do use cases is you apply an MVC pattern to the whole use case description. So use case has a sunny day scenario and a bunch of rainy day scenarios, corner cases, edge cases. And what you want to do then is think of that use case in terms of what's the database access look like, that's the model. What do the screens look like, that's the view. And then what's the logic that glues together the view to the model? Those are your controllers. Okay. And when you decompose a use case into MVC, you find all kinds of mistakes with it. And so I've written a bunch of books on how to do that, so I kind of already had that knowledge going in, and that's all baked into Parallel Agile. But the key is it's one use case per developer. So all of this modeling isn't going on at this big 3-month chunk of time at the front of your project, what they call big design up front, which the Agile people hate. It's all going on in parallel, and so the schedule time is compressed. Okay. And the key thing about Parallel Agile is its schedule compression. I mean, that's really the big overriding benefit of it. So then we would take that use case and we would storyboard it out. So this is a storyboard that we did. This was one of my students named Asmita. Did this in CS590 the first semester. Then it was called baddriverreports.com. We didn't have KarmaCam. We didn't have it named KarmaCam back then. But first she storyboarded it. I approved the storyboard. Then she prototyped it in Angular. And that works. You kind of get a bare bones up and running piece of code. And then we fleshed it out since then and made it look better and added some refinements to it. Right. So again, this all happens one use case at a time. People are storyboarding their use cases, prototyping their use cases, designing their use cases. So this is the model view controller diagram. That's the view. That's the screen that the user's looking at. This is the database, videos, bad driver reports, captured images. The logic in between is these controllers. Okay, so it's model, view, control. And that translates at the design level into sequence diagrams that look like that. And the key focus here is, do I have all my corner cases and edge cases identified when I do that? Because most of the bugs in software systems happen from edge cases and corner cases. Sunny day scenarios are the easy part. So one of the things we built as part of our toolkit, and we developed this tool is Spark Systems Enterprise Architect. They're probably the leading market share tool for UML modelers. So we developed an add-in that hooks up to our CodeBot. The add-in is free. And one of the things that we built in it is a use case complexity analyzer. Because if you have this level of description, you can actually analyze these diagrams and see, if this diagram is 4 pages tall, okay, that's a really complex use case. We probably need to split it up. So we just count how many things are inside the use case, and we say, that one's pretty straightforward. Some of these are pretty big, okay? And you might want to consider splitting them. And the reason you do that is that we're trying to set up a project lifecycle where each trip around that spiral takes about a month, okay? So you have a month for proof of concept, a month for MVP, a month to optimize it, and then you can release it in 3 months. And the scope of what you can deliver in those 3 months depends on how many programmers you have working in parallel. So if you have a big system, you get 50 or 100 developers working in parallel, you can knock that whole sucker out in 3 months. But in order to do that, you need to know that none of your use cases are going to take more than a month to do. So we use this complexity analyzer to split those things, help split those things up. And then in testing, we focus on acceptance testing, and we focus on edge case and corner testing. So we actually generate acceptance tests. This is from, really we took it from a book that I wrote about 10 years ago called Design-Driven Testing, where we built some scripts into that same Enterprise Architect tool, this tool. There's another add-in for this that has logic for design-driven testing, and it generates test cases from requirements, from use cases, and it actually generates some JUnit kind of stuff as well. The big reason that we focus on acceptance testing instead of unit testing, because most of what you read about, especially on Agile, is JUnit kind of unit tests, right? And it's all unit test, regression test. The problem with that is that you only write unit tests for stuff that you're thinking about. And the big problems in software projects come from the stuff that you forget about. I forgot that corner case. I forgot that edge case. So Parallel Agile as a process has built into it a focus when you're doing your modeling on identifying all those edge cases and corner cases and then making sure all of them get tested. Okay. If you forgot about the requirement to begin with, you're not going to have a unit test for it. So you're going to get this green JUnit green bar that lights everything up green. It doesn't mean anything because it's only showing you the stuff that you remembered to think about. It doesn't help you at all in the hard part of software testing, which is testing all the edge cases, corner cases, rainy day scenarios, exceptions, right? So that design-driven testing stuff works from this thing that's called a structured specification for your use case. So here you can see these are all the steps of my use case. And then these are, A is for alternate, E is for exception. So those are alternate cases and exception cases. So I'm looking for a report here. There's an exception. There is no report. Or I want to change my sort criteria to change how that report displays. That's an alternate behavior. We generate this logic tree from that description. Then we generate a test case for each path here. So sunny day scenario all the way through, exception case, and alternate case. And those get generated into human readable English acceptance test scripts. And so what we're trying to do is go faster without increasing your defect count, okay? You can generally go faster on a software project by cutting corners and not worrying about your rainy day scenarios and sweeping them all under the rug. And some Agile methods, extreme programming, for example, has an acronym for do the simplest thing that can possibly work, okay? Well, the simplest thing that can possibly work is you just code the sunny day scenario. You don't worry about the rainy day scenarios. You can get that up and running fast, okay? But if you try and ship it, it's full of bugs, right? So we're trying to go faster, but without increasing the defect count. So you need to test those corner cases and edge cases. On the project management side, we use something called, I call it a sprint plan. And so the blue boxes here are user stories. So I'm not sure if you can read this, but as a user story, I want better video quality, okay? And so a task, the green are tasks. So blue is user story, orange is epics, and the green are tasks. So this is how I organize the projects. And so the task underneath better video quality is implement camera settings. Okay, so I have low light mode, for example, on my camera, right? So, and then I assign the tasks. Each one of these tasks goes to a CS590 student, basically, right? So CS590 is directed research. They sign up. I organize, I recruit my team, see who I got, and then I assign them tasks this way. And I track my project management. So it's very much the Agile project management paradigm, but with some UML technical design added in. So one of the pieces of conventional wisdom and it's called Brooks' Law. Have they taught you Brooks' Law yet in here? Brooks' Law says you can't make a late software project go faster by adding developers. Okay. And Brooks' Law has been around for about 50 years now. Okay. Fred Brooks, when he wrote Brooks' Law, he worked for IBM. He was a manager of a big, huge project called OS 360, which was a massive operating system for a big IBM mainframe in like mid-1960s, early 1970s. Okay. The premise of parallel agile is, sometimes you can actually accelerate late projects by adding developers. And we do this all the time in the CS590 projects. When you have a group of people working on tasks in parallel, there's basically going to be three outcomes. Okay? They're either going to complete on time, they're going to complete early, or they're going to run late. It's only three possible outcomes. If you take the people that complete early and you put them back into a resource pool, you can add them to help the people that are running late. I do this all the time, and it works well. The good news about this is that usually the people that complete early are your most capable developers. Okay, so you get your smartest and best developers complete their tasks early, and then you can add them. And as a generalization, the people that run late are not your strongest developers, right? So you can take your strong developers and give them to, have them help the people that are running late. Actually, it works well. I do it all the time. I do this in CS590 routinely. So I've never been a fan of Brooks' Law, and I'm trying to repeal it, actually. So one of the things that happens when you're working with large teams of developers is that you have to keep track of multiple source code baselines. So we have, for example, on KarmaCam, an Android baseline, an iPhone baseline, a web app baseline. Now we have a machine learning baseline as well. And every week during the semester, we're integrating work from different developers into our baselines, and then build the baseline and acceptance test it. Okay. So our project GitHub for KarmaCam has like a crazy number of baselines in it right now. But these are real things that we were working on last semester on KarmaCam. So baseline management becomes pretty important. So now there's the question, what if you don't have a large team? And most of the industry has been told for so long that they can only do small team agile projects that this is pretty much the situation that we're going to encounter most of the time. So what you can do is you can basically kind of devolve this back down to Scrum, but you can still take advantage of the code generator. You can still take advantage of the acceptance test case generation. You just have to, the project management is a little different. There's different things that you can vary and you can fix. So in Parallel Agile, we fix the scope and we fix the time, but we vary the team size, okay? Whereas in Scrum, your team size is fixed and the sprints are fixed at 2 weeks, but the scope changes, okay? So your scope is, what can my small team accomplish in 2 weeks? But when you do this small team agile stuff, you have to do all this backlog management. And you have product backlogs, you have sprint backlogs, and your user stories go in the product backlog, and you take them out and you put them in the sprint backlog, break them into tasks, and then the small team goes through and they chunk off these tasks over 2 weeks. And there's a lot of moving parts and pieces. A lot of companies get it wrong. When they get it wrong, the projects kind of break down. It's much simpler to just get a large team and have everybody work in parallel, if you could do it. Okay. You can't always do it. But you basically have this, I take my product backlog, I take some tasks, I move them into the sprint backlog. They go from the in process and complete. And you're all working in this tiny 2-week space. So you have to go through this big, Kanban board, Scrum board thing every 2 weeks. It's not for me, but that's what mostly goes on in the industry. And the problem is, you're just in this never-ending cycle of 2-week sprints. And you don't get done very fast, which is not very satisfying for me. So part of what we're doing on KarmaCam is machine learning. So we're doing OpenCV, TensorFlow, image analysis. So we have vehicle detector, stop sign detector, red light detector, license plate reader, and we're following the same life cycle on that of proof of concept, then MVP, then optimizing. So we've done the proof of concept. We're doing AI scoring of incident reports. And just as an example, suppose I report a car for running a red light, and I upload a video that shows that car running a red light. What we're going to do is we're going to score that report by saying, we're going to run the traffic light detector and says, is there a red light in the video? Okay. If there's no red light in the video and it was reported as running a red light, then we're going to score it kind of low. We have a license plate reader. Can we read the license plate number that was reported in the video? So if we can't find, if OpenALPR can't find the car by license plate anywhere in the video, we're going to give it a low score. But if we can find the vehicle that got reported and a red light in the image, then that score is going to go up. And we're using machine learning that way to pre-screen what our human reviewers are going to look at. We're not eliminating human reviewers because I don't trust the machine learning stuff yet. But we're going to pre-screen all the incident reports using ML that way. So this is our actual sprint plan diagram from 2 or 3 semesters ago. And those are the names of the students that actually were working on that. Some of these students actually wound up on my payroll. So this is basically scoring the videos for dangerous driving. And then we're actually doing DUI detection. So we're actually just looking at raw, unannotated video, and we're looking for vehicles that are weaving around doing multiple lane changes at high speed using ML. And we're routing those videos that pass that screening directly into an app that we've designed for law enforcement to be able to get the drunk drivers off the road quickly. The reason we focused on this problem, just by the way, as an aside, is that it's a huge problem. I started doing it. I started the project just because I got pissed off one day at a car that almost caused me to have an accident. And I started researching it once we started building it, and the numbers are staggering. In the U.S., someone gets killed every 15 minutes, somebody gets injured every 15 seconds, and there's $1 trillion a year worth of property damage. And so it's one of these big societal problems that no one's figured out how to do anything with it. So I'm happy it's made as much progress as it has. So this is part of what we're doing in CS590. This is the DUI detection stuff. What you need to detect drunk drivers is you need to be able to detect vehicles. You need to be able to track them across multiple frames of a video. You need to be able to identify lane boundaries. You can see this one was not quite perfect, okay? Still tuning that one. And then you look for a vehicle like this one that's crossing the lane boundary. You can count those things. And you need a different kind of TensorFlow beastie called an LSTM, which stands for long short-term memory, to put those things together. So that's some of the stuff we're working on for KarmaCam. So basically, if you've seen, so this view of ICSM is basically this spiral unwrapped into a linear view, right? This spiral simplifies into this, okay? And so it's proof of concept. Here it says concept of operation, minimum viable product out in here, and then optimized. And of course, you can go multiple times around this optimized loop. So each one of these phases would take about a month. And, we spent 2 or 3 passes on optimizing, KarmaCam now, because that's how this is Dr. Boehm's chart, the key point on here is that we don't only do the development in parallel, we also do testing in parallel. So as soon as somebody completes a task, we try to run it through acceptance testing immediately. And ideally, when you staff these projects, you have a team of testers that's working alongside of the developers. Typically, I try to get about one tester for every 3 developers. That seems to be a balance that works. So the unique thing about Parallel Agile, as far as I know, is that it gives you a chance to deliver a pretty large project in 3 months. There's no other software process that I'm aware of that gives you that same opportunity to do that. So we think we're onto something.